Hello everyone, how are you doing today? Sorry I'm not there to be there for this, but you still got some notes and you're going to do them by watching this video, okay? Today's section 11.2, which is exponential function word problems. Okay, we're talking about exponential growth and exponential decay. Exponential growth occurs when a quantity exponentially increases over time. Our formula for this is y equals a times 1 plus r, and that's raised to the t power. A is your initial amount, basically the amount you start with. R is the growth rate, that basically the rate the initial amount is increasing by. This is usually given as a percentage, and you'll have to convert to decimal, which you do that by moving 2 decimal places to the left. And then you have a time, which is t. So let's do some examples. Okay, I'm not going to do all of them for you, so you don't have to watch a super long video. Number 1, the original value of an investment is $1,400. That is our initial amount, so that's our A. So 1,400 times the 1 plus r. Our r is 9%, so r is equal to 0.09. So 1 plus r would be 1.09, and the t is our time, which is 25 years, so raised to the 25th power. And now we do this in our calculator. I'm going to type in 1,400 times, I'm going to type in 1.09, paste my exponent button, and then plus 25 in there. This comes out to be $12,072.31. So what this is telling me is that after 25 years, $1,400 increasing at a rate of 9% would now be $12,000.31. So if I have a savings account that gets a 9% interest, that means that if I've done nothing to this money but put it in an account, after 25 years it'll have grown to $12,000 roughly. Okay, that's one somewhat with money. A lot of these are done with money. Okay, next one is pretty similar as well. Let's do number 3. The number of student athletes at a local high school is 300 and is increasing at a rate of 8% per year. Use an exponential function to find the number of student athletes after 5 years. Okay, A is 300. R, if it's 8%, would be 0.08. And then t is 5 years, so we have our function. So y equals 300. 1 plus 0.08 would be 1.08. That's all raised to the 5th power because t is 5. So 300 times 1.08 raised to the 5th power. This leaves me with the number of student athletes to be about 400.8. So if you see how this is useful, kind of able to predict the future almost a little bit. Try to model it. See if that's right. Okay. Let's do number 6. In 1985, there were 285 cell phone subscribers in Mayville. The number of subscribers increased by 75% per year after 1985. By the number of subscribers in 2008. So this is our A, 285. The increasing 75%. So 0.75 is my R. Now, it didn't tell me the T, but it tells me from 1985 to 2008. So I'll do 2008 minus 1985. And that gives me, that gives me a T of 23. So my equation is y equals 285 times 1 plus the 0.75, so 1.75 raised to the 23rd power. So 285 times 1.75 raised to the 23rd power Well, I mean, I figured this would be a big number because in 2008 there were quite many more cell phone users than there were in 1985. And of course it is. It makes sense because you're increasing by a 75% rate. So, 1, 2, 3, 4, 5, 6. You get 110 million. 845,988.3 subscribers. That might seem big, but there's that many people using cell phones, okay? Alright, decay. The formula for decay is y equals a1 minus r this time to the t. And the a, r, and t are the same. R is now what we call the decay rate. This is initial amount. And guys, if I'm going very fast, it means you can pause the video. I'm going fast so it's not a super long video for you. Alright, number 7. The population of a town is decreasing. That tells me it's a decay problem. The fact that it's decreasing at a rate of 1% per year. In 2000, there were 1,300 people using an exponential function to find the population in 2008. So here's our A. My time, 8 years has passed. My rate is 1%, so it's 0.01. And we go. So we're doing 1 minus this now. Okay, 1 minus 0.01 is 0.99. So at 1,300, y equals times 0.99 to the 8th power. So 1,300 times 0.99 to the 8th power, and that gives me 1,199.57 people. Okay. Let's do one about an investment when we're talking about losing value. Okay, A is our initial value. Losing tells me it's decreasing or decaying. So my R is 0.02. 1 minus 0.02 is just 0.98. And my time is 9 years. So y equals $8,200 times 0.98 to the 9th power. Calculator tells me that this is going to be $6,836.73. That sucks that it's decreasing. Okay, and that's the gist of it, guys. You're just kind of figuring this out. The decreasing and depreciating, that tells us that it's a decay problem. If it's talking about increasing or getting bigger, that's a growth problem, okay? This is only an 8-minute video, but it's really just kind of taking the word problems and plugging them in. If you have any questions, please shoot me an email. I hope this is enough for you to do your homework. And what I want you to do is try to do the rest of the problems in class, and then you'll get the homework from the sub, and then you'll be good, okay? Thank you, guys. Thanks for being patient with me not being here as well. Have a good day.